Okay, so number 44 on page 740 says a load has a power rating of 160 watts when the current is 6 amps. What will be the power output if the current is increased to 15 amps? So what you want to find is what's the resistance of this load, and you can find that using your P is equal to I squared R. So R is equal to P over I squared. So 160 watts divided by 6 amps squared. And you will get an R of 4.44 ohms. Okay, and you want to do that because remember we said the R isn't going to change, the I and the V are. So now you're going to change your current to 15 amps and it wants to know what's the new power. So now that you have the R that isn't going to change, you just do 15 amps squared times 4.44 ohms, and you get your new power to be 1,000, right on the nose. If you haven't rounded, I think the 4 is repeating. So if you've kept all your digits in there and multiplied it by 225, you get 1,000. Number 45 says, what is the power output of a circuit that consists of a 25 ohm resistor when connected to a 100 volt supply? So power is equal to V squared over R. So 100 volts squared divided by 25 ohms. You should get a power of 400 watts. That's part A. Part B says, if a second 25 ohm resistance is connected in series with the first, what will be the power output? So if you connect a second one in series, now our total is going to be 50 ohms, and your voltage, we're assuming, is still 100 volts, and so power is still equal to V squared over R, so still 100 volts squared, but this time divided by 50 ohms, so you're dividing by twice as much, you should get half as much, 200 watts. Okay, so there's some power ones. We will have a few more for tomorrow, but before we go there, we have 2 complex circuits to do. So number 3 on your sheet, let me make this bigger. There we go. It has a little twist in it because you don't know R5. But you're still going to simplify and do everything the same. So what would you put together first? Well, remember the total current is leaving the power supply, and now it's splitting before it goes through anything. So these are in parallel with each other. And the same current flows through here. So I would put 1 and 2 together, and I would put 3 and 4 together. And I would get a circuit that has 1, 2 in this branch, 3, 4 in this branch, and 5 out here by itself. And now when you look at that, you should be able to see it's a series circuit. This is R12, or excuse me, it's a parallel circuit. This is R12 here, and they're in series with each other, so you can get R12 easily, just add them up, 30 ohms. 3, 4 in series with each other, you can get its value, get R34's value easily, because they're in series, just add them up, 10 ohms. And R5 we don't know. But over here we're given an I. And what I is that? That's I total. So if we go to our givens, we have 30 volts and we have 10 amps. So our I total would be 30 divided by 10. It's 3 ohms. And so now we can find our R5, because 1 over R total is going to equal 1 over R12 plus 1 over R34 plus 1 over R5. And the only thing we don't have is R5. So 1 over R5 is equal to 1 over R total minus 1 over R12 minus 1 over R34. So 1 over our total was 3 ohms, minus 1,2 was 30, and 3,4 was 10. Common denominator is 30. So 1 over R5 is equal to 10 over 30 ohms minus 1 over 30 ohms minus 3 over 30 ohms. That should be 6 over 30 ohms. Therefore, R5 is equal to 5 ohms. And now once we have that, we can fill in the rest of our stuff. So this is 10 ohms, this is 20 ohms, this is 30 ohms, this is 4 ohms, this is 6 ohms, this is 10 ohms, and this is 5 ohms. Okay, so now that we have all our R's and our totals, now we look at our most simplified circuit and we say, oh, it's in parallel. And in parallel, what's the same? The voltages. So V12 should be equal to V34, should be equal to V5, should be equal to V total. So 1,2 should be 30 volts, 3,4 should be 30 volts, and 5 should be 30 volts. So I5 is going to be 6 amps, I34 is going to be 3 amps, and I12 is going to be 1 amp. We finished our most simplified. Now we step back. R34 replaced R3 and R4, which were in series, and in series the current is the same. So I3 should be equal to I4, should be equal to I34, which was 3 amps. So this is 3 amps, this is 3 amps. 3 times 6, 18 volts. 3 times 4, 12 volts. Add them up, they give me back to 30. Now we look at R1 and R2. They're connected in series, and they were replaced by R12. In series, the current is the same, so I1 should be equal to I2, should be equal to I12. So 1 amp and 1 amp. And now multiply up, 10 volts, 20 volts, and you are done. If you take a look at the whole table, remember, no voltage is bigger than V total. No current is bigger than I total. And again, it doesn't matter about the R's. Okay? All right, on to number 4. The hardest part of number 4, I think, is figuring out what to put together first. There's going to be more than one step here. So the total current leaves the power supply, goes through R1, and then splits. So this branch and this branch are in parallel with each other. But in this second branch, there's a whole bunch of resistors. And the same current flows through all of them. So R3, R4, and R5 are in series. And that is the first thing we put together. Okay, so leave R1 right where it is for now. Leave R2 right where it is for now. This becomes R3, 4, 5. And leave R6 down here. Okay, so R1 is still 5 ohms. R2 is still 6 ohms. R6 is still 15 ohms. And R3, 4, 5 becomes 5 plus 10 plus 15, it's 30 ohms. Okay, but we're still not completely simplified because there's still a series parallel. So now we're going to put 2 and 3 together. And you couldn't have put them all together at once because these were series and now this is parallel. So in our next step, it'll be R1, R2, 3, 4, 5, and R6. So R6 is still 15 ohms. R1 is still 5 ohms. And now we have to find 2, 3, 4, 5. 1 over R2, 3, 4, 5 is equal to 1 over R2 plus 1 over R3, 4, 5. So 1 over 6 plus 1 over 30.